All right, let's talk about more about the polynomial functions within static. So first of all, we have the intermediate value theorem, which says that if I'm dealing with a continuous function, then if I have a positive value for some x input and a negative value for a different x input, then somewhere in between those, that continuous function must cross the x-axis. So it must have a 0 in between the a and the b. All right, let's lose that here. All right, we want to show that the polynomial function defined by negative x cubed minus x squared plus 5x plus 5 has a real 0 between 2 and 3. So first of all, p of x is continuous since it is a polynomial with domain of all real numbers, right? There are no interruptions in it. Now, why do I have to state that? Because this is only true if my function's continuous. If I've got a break in here, then it may not necessarily be the case. So I first have to state that the function is continuous. Then, if I plug in 2, I get negative 2 cubed minus 2 squared plus 5 times 2 plus 5. That's negative 8 minus 4 is negative 12 plus 10 is negative 2 plus 5 is 3. Doesn't matter what the value is. The fact is it's positive. Now let's look at 3. If I plug in 3, I have negative 3 cubed minus 3 squared plus 5 times 3 plus 5. That is negative 27 minus 9 would be negative 36 plus 15 would be negative 21 plus 5 would be negative 16. Again, it doesn't matter that. It just matters that it's negative. Well, if one side is positive and one side's negative, then we must have a 0 between the two values by the intermediate values. All right, now I want to divide this polynomial 3x cubed minus 2x plus 5 by x minus 3 to get the quotient and the remainder. So the first thing I'm going to do is I'm going to set it up as 3x cubed plus 0x squared minus 2x plus 5. I'm just bringing this guy down there. And then I'm going to divide the x minus 3 on the outside. So I'm putting the x minus 3 over here. Now the first thing I do is ask myself, what do I need to multiply x by to make it look like 3x cubed? And the answer is 3x squared. So 3x squared times x is 3x cubed. 3x squared times negative 3 is negative 9x squared. Now subtract these two. 3x cubed minus 3x cubed is 0. 0 minus negative 9x squared is a positive 9x squared. Now I'm going to bring down the negative 2x next. So negative 2x comes down, bring down the negative 2x, and then ask myself again, what do I need to multiply x by to make it look like this positive 9x squared? And the answer is 9x. So 9x times x is 9x squared, 9x times 3 is negative 27x. So 9x squared minus 9x squared is 0. Negative 2x minus negative 27 would be a positive 25x. Bring down the 5. Okay, now we ask the question again. What do I have to multiply x by to make it look like 25x? And the answer is going to be a plus 25. So I put the 25 here. 25 times x is 25x. 25 times negative 3 is negative 75. 25x minus 25x is 0. 5 minus negative 75 is 5 plus 75, so 80. So my quotient is here, and the remainder is here, because there's nothing I can multiply x by to make it look like 80. So I write the answer as the quotient plus the remainder over the divisor. So this is my divided form of that fraction. If the degree n polynomial is divided by x minus k, then the quotient polynomial will have 1 degree less. The remainder will be a constant, And the complete form would be written as that quotient plus the remainder over the divisor. All right, now, this is the division that we just did. If we take away all of the x's, it looks just like this. So notice I can do the same thing. I can say, what do I need to multiply by to get that here? Well, notice I would multiply by a 3 to make those look the same. So 3 times 1 goes here, 3 times negative 9, and do it going down, right? So I can strip out all of the variables and have a condensed version of the long division, which is known as synthetic division. So in that synthetic division, just bring the 3 down, and then we would multiply 3 times 3 to get the 9, add going down to get the 9, 3 times 9 is 27, add going down to get the 25, 3 times 25 is 75, add going down to get the 80. And we see we end up with exactly the same answer we did by the long division process. But the synthetic division is a little bit faster. All right, so let's use synthetic division here. So now notice, by the way, over here, I was dividing by x minus 3, so we changed the sign on the synthetic division and made this a positive 3. So I do the same thing here. So since this is a negative 3, I put a positive 3 on the outside, and then the coefficients of, and I write my division bar this way instead of the other way, just because it's easier in lining up the synthetic division. So it's 1x cubed minus 2x squared, 0x minus 9. Don't forget the 0x term that's missing from here. Okay. Now we bring down the 1. 3 times 1 is 3. Add going down, we get a 1. 3 times 1 is 3. Add going down, we get a 3. 3 times 3 is 9. Add going down, we get a 0. So this is 1 degree less than x cubed. So 1x squared plus 1x plus 3 plus the remainder of 0 over x minus 3. So I don't write it since it's 0. Now, notice also that this division is saying x cubed minus 2x squared minus 9 divided by x minus 3 equals this quotient, x squared plus x plus 3. That's a true equation because the remainder was 0. So I could multiply this to the other side, and I get x cubed minus 2x squared minus 9 equals x minus 3 times x squared plus x plus 3. In other words, when I have a remainder of 0, it's a factor of the polynomial. This is now the factored form of this polynomial. So if a polynomial is divided by a term, the remainder is equal to what I would get if I evaluated this number in there. Again, notice it's changing the sign. This was a minus k, and it's substituting a positive k in there. All right, so I want to use synthetic division to evaluate p of negative 2. Now, by the way, I could very easily just plug in the negative 2. Negative 2 squared is 4. Minus 10 would be negative 6 plus 6 is a 0. Let's get it with synthetic division, though. Put the negative 2 on the outside. 1, 5, 6. Bring down the 1. Negative 2 times 1 is negative 2. Add. 3 times negative 2 is negative 6. Add. My remainder is 0. That's what it evaluates to. So p of negative 2 must be 0. All right, so I want to determine whether negative 4 is a 0 of this. So we'll do it again with synthetic division. So 9x cubed plus 39x squared plus 12x plus 0 is the constant term. And I want to divide by negative 4. So bring down the 9. Negative 4 times 9 is negative 36. Add going down, we get a 3. That's a negative 12. Add going down, we get a 0. Multiply by negative 4, that's a 0. Add going down is a 0. We got a remainder of 0. Yes, negative 4 is a 0 of that function. The polynomial has a factor if and only if we evaluate it to 0. That means if the remainder is 0, like I showed you in the first example. So I want to factor this into linear factors given that negative 5 is a 0. So if negative 5 is a 0, that means when I divide it out into 8x cubed, 50x squared, 47x, and negative 15, I should get a remainder of 0. Bring down the 8. 8 times negative 5 is negative 40. Add going down, negative 50. Add going down is negative 3. Negative 5 times negative 3 is a positive 15. down, we get a remainder of 0. So this polynomial factors into x minus this 0. So x minus negative 5 is x plus 5. And then this, remember, starts 1 degree less, times 8x squared plus 10x minus 3. Okay, now this is a quadratic, and so I can factor it again. X plus 5. All right, now I'm looking at the factors of 8 and 3. That'll make a 10. So notice that 4 times 3 is 12, and then 2 will take me back to 10. So I'm going to go 4x and 2x to get the 8x squared. And I want the 3 to multiply here, and I want the result to be positive. So this needs to be a positive and this a negative. 4x, that would be 8x squared plus 12x minus 2x minus 3. We've factored it correctly. There is our complete factored form, the linear factors. If p and d are two polynomials with the degree of d greater than 0 and less than the degree of p, then there exists unique polynomials q and r such that we can break it down into that quotient plus remainder over divisor, where either r is 0 or the degree of r is less than the degree of d. Let's divide this. Okay, I can't do the synthetic division, so I'm going to do the long division. Why can't I do synthetic division? Because this is an x to the first. I can only do synthetic division when this is x to the first in the denominator. So x squared plus 3 dividing into x cubed minus, minus x squared plus 2x minus 3. All right, what do I have to multiply x by to make it look like x cubed? So x times x squared is x cubed plus 3x, but line it up with its term. Now subtract. X cubed minus x cubed is 0. Negative x squared minus 0 is a negative x squared. 2x minus 3x is a minus x, bring down the negative 3. Now what do I have to multiply x squared by to make it look like negative x squared? That's a negative 1. So negative 1 times x squared, negative 1 times 3. Subtract. Negative x squared minus x squared is a 0. Bring down the negative x. Negative 3 minus negative 3 is a 0. And I can't make x squared become an x. So this divides into x minus 1, the quotient, plus negative x over the x squared plus 3. And there's my breakdown, right? We're just doing the quotient plus the remainder over the divisor.